Yay!
Yay! Now we can make a little magnetic elevator using the magnetic force on currents. So here's what we do. Suppose I got a little bar of mass m, and the idea is that m can sort of ride up and down on those rails. So maybe this is like vertical, so the gravitational force on the bar is pointed down, and it's in the middle of some magnetic field going into the page that's like half a Tesla. And I have some voltage source with a resistor up there. So what I'm going to do is I'm going to pipe some current through that bar that has a mass m, and the magnetic force on it, if I do it right, the magnetic force is going to counter the gravitational force, and the bar should just hang there. So let's figure out, first of all, what direction does that current have to be? We know that the magnetic force on a current is just IL cross B, right? And I want that force to be up. So I want the magnetic force to point this way, like that. So this is going to be my magnetic force. And so if that's going to be the case, what has to be is that the current has to travel to the right. So this has to be the direction of I, if you do your right-hand rule. And so that tells you sort of the polarity of the voltage source that you got to hook up to make sure that the current is going that way. All right, so now we just got to figure out how much voltage to apply. And you can see how we're going to get there. If I want to know the voltage, it's the I that's going to get me there, because I can just use Ohm's law to figure out the voltage. So, okay, let's do that. What I want is I want this thing to just hang there. So what I really want is this I, now L cross B, that's LB sine theta. But again, the theta between the direction of the current, that L, and the magnetic field is 90 degrees. So sine of theta is just 1. So this is going to be, let me write that out, ILB sine theta, but that's just going to be 1. So what I want is the magnitude of the magnetic force, ILB, to just equal mg, right? And then this thing is just going to hang there. So the I is just going to be mg over lb. But the I is just b over, delta v over r. So there I have it. So my delta v, the amount of the voltage of the battery or the voltage source that I have up there, is going to have to be Rmg over Lb. And then I can get this thing to be suspended. Okay, so again, it's kind of fun just to put numbers in just to see if this is a reasonable, like, could you actually do it? Is this a reasonable kind of a thing? So yeah, let's do it. Let's say that the mass, let's say M is 100 grams. Let's say our B, we already said, was half a Tesla, right? So it's 0.5. The L, let's say that that's just an ordinary size, like a 50 centimeter bar, so that's not a big deal. What else do we need to know? MLB, G, we already know that. R, we said, is 10 ohms. Looks like we're ready, right? So this is going to be R, this is going to be 10 times 100 grams is 0.1 kilograms, always SI units. G is like 10, pretty close. I'll be honest, and I'll put my little squiggle in there. L is 50 centimeters, so that's going to be 0.5 and 0.5. So what? That looks like 10 over a quarter, so that's going to be 40. 40 volts. There we go. So if I supply 40 volts, I can get this thing to just hang in the air. And you can see how this might even be a little elevator or something, right? If I increase the voltage a little bit, then the magnetic force is greater, and so I'm going to lift it up. If I decrease the voltage, if I can sort of turn it up or down, if I can tune this thing, then I can make the bar sort of raise up and down. So, you know, in this sense, maybe we can make a little magnetic elevator. All right.